Hey guys, so I wanted to explain to you how to do a problem like number one on your homework because it is a little bit confusing on your assignment. So here we go. This example is not the same as your homework problem, but hopefully this will give you enough information to complete yours. So the first part of the question is basically asking you to complete a number line, or also known as a sign chart, for velocity and acceleration. So we're going to back up and we're going to go find our velocity and acceleration functions up here at the top, which is just our derivatives. So our velocity function is 3t squared minus 18t plus 24. And the acceleration function would then have to be 6t minus 18. Okay, so what I want to do down here is I want to just pick some t values to see what this particle is doing, and there's not a lot of information provided about what t values to use other than start at 0. So what I did is I just kind of went from 0 to 5, and then I'm going to plot those points on a number line. So I've already done that. I am using the values here in this chart. I made a little table because I like that better. And this is my position function. I'm not going to do anything with those values yet. I'm going to take these velocity values and I'm going to plot them on the number line, but I'm going to plot them in a way that just shows the sign. So with that information, here's what I mean. So I've got 0, I'm going to go 1, 2, 3, 4, 5. And all I want to do is say, what's the velocity at 0? The velocity at 0 is 24, is a positive number. The velocity at 1 is 9, still a positive number. So the velocity is positive all the way through here, positive at 1. And it's positive until we get to 2, and that's when the velocity is equal to 0. At 3, the velocity is negative. At 4, the velocity is 0, so it's negative all the way through here until we get to 0. And at 5, the velocity is 9, so it turns back and goes to positive again. So that's all I'm looking for right there. Acceleration, I'm going to do the same thing. I'm going to try to space it out evenly so that I can very easily compare this particle's movement from one number line to the other. So here's my acceleration data that I've already done. I start with negative, I hit 0 when I get to t equals 3, and then positive. So I'll go maybe do this different. I'll put the 0 on there and then just throw negatives in up to that point, and then positives after, because we said it's positive after 3 seconds. All right. Next part is tell whether the particle is speeding up or slowing down. So I'm going to put the same values, kind of lining them up with the two number lines I created above. And I'm going to try to compare and see, from here to here at 1 second, does my velocity match my acceleration? They do not, which means that my particle is slowing down. And actually, that's true all the way up to 2. So from 1 to 2 seconds, we are slowing down. At 2 seconds, we have a shift. From 2 to 3 seconds, our velocity and acceleration have the same sign. And then it changes again after 3 seconds. So if you look right here, between 2 and 3 seconds, they have the same sign. So that means it's going to be speeding up. From 3 to 4 seconds, opposite signs again, means slowing down. And then from 4 seconds on, they are the same sign again. So we're doing another speed up. Okay, so that's why it's helpful to have all your seconds lined up like this on the first two number lines. That way you can easily compare when you get down to here for your acceleration. The last thing is for position. So what we're going to be doing is we're going to be using the position values. And again, you just find these by plugging them into the original function, 0, 1, 2, 3, 4, 5, plugging those in. We're going to plot these on a number line, and we're going to show particle movement. So 4, 20, 24, 22, 20, 24. We're going to plot those. So I'm going to kind of try to make it look spaced appropriately. Okay, those are the 4 values. And I'm going to start here and I'm going to put a dot. And at that dot, that is t equals 0. There's another dot at 20. So this is my particle moving to the right. That's at t equals 1. Then we have a dot at 24. That is at t equals 2. And then the particle goes back to 22. So here's what's going on. My particle is going like this. And then at at t equals 2, the velocity is 0. So that means it turns around and comes back to 22. And then we go to 20 again. So we go back. We keep going in the negative left direction. And then the particle stops and turns around again and lands at 24. So that's just showing our particle's motion. That's an example. Hopefully that helps you with the first problem on your homework. If you have questions, be sure to ask me in class. Thanks.